What's up, you guys? Thank you for joining me again. Now, welcome to our final chapter of AdMaths. Okay, we have already covered all the chapters. This is the final one for AdMaths Form 5, Chapter 8, which is Kinematics of Linear Motion. Now, this is a rather simple chapter, and similar to the previous chapter, I would highly recommend you guys to master this, okay, so that you can answer in your exam. But no worries, if you find it hard, that is why we have this video for you, and I'll try to cover as many examples as I can in this video, or maybe I'll break it into part 2 video, okay, so that when you go through more examples, you'll find it easier to understand the chapter, right? So without further ado, let us get started. Okay, so what is this chapter all about? So in this chapter, you need to know 3 things. The first thing is displacement. Second thing is velocity. And the third one is acceleration. Okay, I'm sure you have already learned this in your physics. So this should be like something easier for you all to understand because you already learned before. So what is displacement, velocity, and acceleration? So let's start one by one. Displacement is similar to distance, okay, but of course there's a difference lah. Displacement is similar to distance. Velocity is similar to speed. Okay, and what is the difference? Okay, let's say displacement and distance. Let's say you are traveling from, let's say you got a ball, okay, and then this is on a flat plane, okay, it's on the floor. Now this ball rolls here, okay, it rolls by, let's say, 5 meters. So it comes here, and then it rolls back. Now the ball stops here. I draw it floating. Let's say the ball stops here. So here is let's say 2 meters. Okay, so the ball rolled to the right 5 meters and then rolled to the left 2 meters. So at this position, if I ask you what is the distance, the distance you would have to consider the total journey. So that means from here, travel 5 meters to come here, and then 2 meters to come here, right? So total is 5 plus 2 meters. Sorry, 5 plus 2, not 5 plus 7. 5 plus 2 equals 7 meters, okay? But if I ask for displacement, displacement means the shortest distance, okay? Shortest distance from the initial position. So if here's the initial position, the shortest distance would be here. So that means you have to take, total is 5 meter minus 2 meters, so it's 3 meters. So the displacement is the position, the final position compared to the initial position. That means the shortest distance, okay? It does not take into account the total journey. Okay, this is important to know because some people make mistakes when it comes to this chapter. They think it's the same thing and then they end up doing it the same. It is not the same, okay? Displacement and distance is not the same. So let me just go straight to the topic, okay? So if let's say you have, same thing, you got a ball here. Now, at the initial position, that means here's the starting point, right? At this position, S is equals to 0 because the ball haven't moved yet. It's still at the original position. So displacement equals 0. So by the way, in case we usually represent displacement as S, velocity as V, acceleration as A. So in this case, S is equals to 0 because it haven't moved yet. Now if the ball moves to the right, if it moves to the right, this is when S is more than 0. So it's a positive value. Okay, S will be more than 0. If it moves to the left, that means it's S less than 0, which is a negative value. So in other words, if I tell you the distance is negative 3 meters, so you should already know from here that, let's say the ball has already traveled 3 meters to the left. because negative means left. So that means here is the original position, and the distance from the original position is 3 meters, and it's to the left. Okay, if I say s equals to positive 4, so you know it's a to the right, it's 4 meters to the right, so the ball will be maybe somewhere here. So the distance from here to here is 4 meters. Clear? So you must understand the positive, negative. Positive means right hand side, negative means left hand side. So same thing applies to velocity. When you, okay, let's say same thing, you've got a ball here in the middle. This is the starting point. Now, if the ball is not moving, okay, if it's not moving, or you can say if the ball is stopped, or the ball is stationary. Okay, there's so many ways you can say lah. Okay, if it's not moving, that's when you know velocity is equals to 0. Okay, because it's not moving, so therefore there is no speed. Okay, so the velocity v is equals to 0. Now what if you see a positive velocity, let's say positive 3 meter per second. Okay, positive 3, that means it is moving at this speed to the right. So that means if it's here to the right, it's v more than 0. Okay, so it's a positive. So positive means velocity is moving to the right. Okay, similar to displacement. So if it's moving to the left, same thing, v is less than 0, so it's a negative value. Clear? So if you see, they tell you the particle is traveling at this speed, negative 5 meter per second. So you should know that it's traveling to the left at this speed, 5 meters per second. Clear? Alright, so that is for velocity and displacement. Now, acceleration. Acceleration is a bit different. Acceleration, there is no right left. Okay, acceleration is, you first have to understand what is acceleration. Acceleration means the change of velocity. Okay, the change of velocity. So for example, let's say you are traveling to Penang. Okay, you see your father driving. Your father at first driving at his speed. You see his meter. He's driving at 90 kilometer per hour. Okay, let's say he's driving at this speed. Then after a while, when you see his meter, you notice he's driving at 110 kilometer per hour. Let's say, so his initial velocity is right here. Initial velocity is 90, right? And then let's say his final. So final velocity is 110. So there is a change of speed, correct? Went from 90 to 110. So because of this, the acceleration is positive. It's a positive value. That means a is more than 0. Okay, this has got nothing to do with direction. It's not like velocity where you go right means positive, you go left means negative. No, if it's positive, that means the velocity is increasing. Okay, the velocity from 90 going to 110. So that means the velocity is increasing. Okay, now if it's reducing, let's say initial is 110 kilometer per hour, and then he went to 90 kilometer per hour. Okay, he slowed down. So when he slowed down, that means your velocity is decreasing, right? So that means your acceleration is less than 0. That means negative value. Okay, so if I tell you acceleration is positive 3 meter per second square, that means you know that positive means what? The velocity is increasing. Okay, it got nothing to do with direction. It's not saying that it's going to the right or going to the left. No, it's just telling you velocity is increasing. If it's a negative value, that means the velocity is reducing. Clear? So I'm going to write here if you see positive, okay, a is more than 0, that means a positive. In this case, the velocity is increasing. Okay, if a is less than 0, that means it's negative value. This one means deceleration. In other words, you learn in physics, right? Positive means it's accelerating, If it's negative, means it's decelerating, it's going slower. So your velocity is reducing. Clear? So yeah, this is the basic that you have to know about these three displacement, velocity, and acceleration. Now, how do you relate from one to another? How do you relate, like for example, displacement? How do you change displacement to velocity and then change to acceleration? How? Is it like this? I'm going to write here S V A. Okay, displacement, velocity, and acceleration. If you want to change displacement to velocity, okay, if you want to change displacement to velocity, you have to differentiate ds. Okay, right here. So v will be equals to ds dt. That means you have to differentiate your displacement function. Okay, you differentiate your displacement function, you get your v. Okay, velocity. If you want to find acceleration, what you can do is you have to differentiate your velocity. Okay, so in other words, if you're going from displacement to velocity to acceleration, you always have to differentiate. So if you want to go reverse, what's the opposite of differentiate? You have to integrate. So if you want to find velocity using acceleration, you have to integrate acceleration. Okay, and same thing here. If you want to find displacement using velocity, you have to integrate your velocity. Okay, so this is the relationship between the three things here. Okay, how do you translate one to another? Okay, so now is where the crucial one comes in. Knowing all this, what I've just showed you, all right, how can the question ask? So sometimes the question can ask, for example, they ask for total distance. Okay, if the question asks for total distance, the formula is like this. Total distance means you integrate v dt. Because why? See here, you integrate v dt, you get displacement, right? So you want to integrate the whole journey. Okay, I'll show you all later how to do it. Okay, don't worry, right now if you don't understand, it's fine. I just show you all the formula so that later you will know what to do. Okay, so S equals to v dt. Okay, so this is the formula. Okay, if they ask for total distance. Now if they ask for maximum or minimum displacement, okay, maximum or minimum displacement, you have to assume sorry, maximum or minimum displacement, you know that v is equals to 0. Okay, v is equals to 0. See, all this is under the displacement side. So if they ask for total distance, this is the formula. If they ask for maximum or minimum displacement, velocity equals to 0. Okay, now since velocity is also the same as ds dt, which is the differentiation of s, so you can say ds dt also equals to 0, either one. Okay, they are the same meaning lah. V is actually the same as, these two are the same thing. ds dt is the same as velocity. Okay, so it's equals to 0. Now what about velocity? What they can ask, they can tell you, for example, here you already know, this one you should know. Whenever they say it's not moving, or the particle is stationary, or it comes to a stop, that means you must know velocity equals to 0. What else they can ask? They can also ask maximum or minimum velocity. Okay, if they ask for maximum or minimum velocity, you take acceleration equals to 0. Okay, acceleration equals 0. Now acceleration is also the same as dv dt, so dv dt equals to 0. Okay, same thing lah, I just write there for your info. Okay, alright, I think velocity, that's all. So now what about acceleration? So acceleration, what they can ask is so they can tell you, for example, the particle move at constant velocity, or you can say uniform. Okay, maybe they don't say constant, they can say constant velocity or uniform velocity. They are the same thing lah. Okay, in other words, you notice that constant means there is no change, right? I told you that acceleration means if the speed is increasing, there is acceleration. If the speed is decreasing, it's deceleration. But if it's constant velocity, no change. If there is no change, acceleration is equals to 0. Okay, please bear this in mind. Yeah, so that's more or less what you need to know for this chapter. These are the 3 parts, and also how do you relate from one to another. Okay, so let us go straight to some examples. A particle moves along a straight line and passes through a fixed point. The velocity is given by, okay, so they gave you the velocity, okay, where t is time in seconds after passing through. Oh, okay, question A. Okay, let me just write down. They gave you velocity, right? Velocity is v equals to t square minus 8t plus 7. Okay, so this is the function. Now they said find the instantaneous velocity of particle when t is equals to 3. They want you to find the velocity when t is equals to 3. So just substitute. So when t is equals to 3, v would be equals to substitute 3 into the t. So 3 square minus 8 times 3 plus 7. You get 9 minus 24 plus 7. So your answer should be negative 8 meter per second. Because they told you velocity is meter per second. So negative 8 meter per second. So that means they are moving at 8 meter per second to the left because negative. Okay. Question B. Question B, they asked to calculate the value of t. So they want to find time when the particle stops instantaneously. So if it stops, what happens? I already told you all just now. When it stops, v is equals to 0 because there is no speed anymore. Okay, stop. So v is equals to 0. So when v equals 0, what is the time? So we're going to solve that. So just substitute into the main equation here. So 0 equals to t square minus 8t plus 7. So you can factorize this quadratic. Okay, use your calculator. You get t minus 7 and t minus 1. So in other words, the time is equals to 1 second and also 7 seconds. Okay, so it stops at 2 times. One is when t is equals to 1 and when time t is equals to 7. Okay, so these are the 2 times that they stop. Okay, next question C. Determine the range. So they want range now. Range of t when particle moves to the left. So I told you all this before. Only 2 things will change when you move right left. Either displacement or velocity. These 2 are affected when if you move to the right, it's positive. When you move to the left, it's negative. So now they said it moves to the left, right? So if it moves to the left, that means the velocity is negative. If it's negative, that means what? Velocity is less than 0. Correct? So this is what it means when they ask for range. Whenever they ask for range, it's always an inequality. Okay, so this is an inequality, less than 0. So in this case, the range, right? So particle move to the left, so that means the velocity is less than 0. So t square minus 8t plus 7 is less than 0. So same thing, you just can factorize. You get t minus 7, t minus 1. Okay, so I'm sure you all learned this before in Form 4 chapter 2, if I'm not mistaken. You learn about inequality. Okay, so whenever you have, I change this to equal sign first. There are 3 ways for you to solve this, right? Either you use a graph method, or you can use number line method, and also I forgot what's the third one. Tabulation method. Yes, so there are 3 ways you can solve. So I'm going to use a graph method. So graph method means, I don't know you all still remember or not. Here is, you already found that, sorry, wait, t is equals to 1 and 7, right? So if you draw your graphical method, here is 1, here is 7. So since this one is less than means here, so that means your t is between 1 and 7 seconds. Okay, so this is your answer. The range lah, they're asking for range, right? So this is your answer. Now if you don't remember this, you go and recap in the form 4 chapter 2 one. Okay, alright, next question. A particle moves along a straight line and passes through a fixed point O. Its displacement after it starts moving is given, so they give you the displacement of the function. Okay, the particle moves to the right of O, so O is the original position, and then it moves to the right until t equals to 3, and then moves towards O again. So that means it moves back to the left. So question A, find the total distance. See, whenever the question asks you to find total distance, right, I would highly recommend you guys to sketch your graph, okay, because it can be very tricky. So in this case, let us sketch the graph together. They gave you the s function, right? So s equals to, so I'm going to rearrange the formula, negative t square plus 6t plus 7. Okay, so it's a negative here, so you know it's going to be a n-shaped graph. Okay, remember I told you all, if it's a positive people are always happy, so it's smiling. Negative people are always sad, so it's a n-shape. Okay, so you know your graph is going to be n-shape, and the intercept is 7. Okay, so what you can do is you can factorize this. When you factorize, you will find your x-intercept. So I already done all this, so your graph should look something like this. Okay, it should look something like this. Sorry. Okay, so here will be 7, here will be negative 1. Here your intercept should be t plus 1, t minus 7. Okay, so yeah, that's how you get the intercept. Here is your s, here is your t, then here is the intercept, which is 7. Clear? So this is how you sketch your graph. Okay, but you don't have to sketch this part. Why? Because there is no such thing as negative time, right? So there is no, that you don't have to draw this part, because the time will never be negative. So there is no, the negative side of the axis you don't have. You only have this side when t is positive. Okay, time is positive. So in other words, when you draw your graph, you should only draw one side. Okay, so your graph should look something like this. Here is 7. Okay, it goes up, then it comes down. Oops, sorry. Goes up, comes down. Okay, so here, you know, is just now, when you factorize this, you will get t equals to 7, t equals to negative 1. So this is the 7. Okay, the x-axis, x-intercept. Here will be time, here would be displacement. So what does this graph tell you? I need you all to understand the graph. So what does this graph tell you? It tells you that here's the ball. Okay, wait, here's the origin, original position O. Okay, point O. Now, when you see, when t equals to 0, right? When time is equals to 0, what is your value of s? 7, right? So what does that mean? It means when t is equals to 0, the ball is not at origin. If the ball is at origin, the graph should start like this. It should be at 0, but it is not. It is at 7. It means the ball was already in front of, on the right hand side of the original position by 7 meters. it was already 7 meters from the original position, and then it continued to go to the right, because you see it's continually going positive, higher and higher, right? So that means it's going to the right. So it goes to the right. So here you can find it's actually equals to 3. How to find? Is the midpoint between the, when you factorize this, right, you will get t positive 1, t minus 7. So you'll get t equals to negative 1 and t equals to positive 7. So that should be your intercept, correct? X-intercept. So you just find the midpoint of this, negative 1 plus 7 divided by 2. So you get 6 over 2, which is 3. So that is your center here. Clear? I'm just showing you all how to draw lah, because I know some of you all probably would have forgotten. Okay, sketching the graph is very important. So in this case, you know this is 3. So that's what it meant here, you see. The ball shifts to the right until t equals to 3. So that's why it's going up, right? You see it's going upward. So it's positive. So it's going to the right. And then when it reaches this point, when t equals to 3, it starts going downward, right? Downward means it's reducing. If it's reducing, that means it's going closer to the original position. And then when it reaches here, when t equals to 7, that's when the displacement is 0, right? So when t equals to 7, the ball is already back to the original position. Clear? So that means initially the ball from 7 meters away here, okay, it moves to the right by how many, I don't know how many meters. So it moves to the right. Let me redraw this. It looks very untidy. So it moves to the right because from 7 meters, you see the graph, it goes up, right? So it's moving to the right. So it moves to the right until, let's say it stops here. So here is t equals to 3 seconds. Here is t equals to 0. So it stops, it's here, and then it moves to the left. Move to the left all the way to here. So when t equals to 7, the displacement is 0. So that means the ball reached here. So at this point, t equals to 7. Okay, and then yeah, so that's about it. So in other words, this is how the ball traveled. Okay, that's why I say you need to sketch the graph. If you don't sketch, you would think that the ball started from origin, moved 3 seconds, and then moved to the left. Correct? That's what you would think. But it's more than that. You see, you got a 7 meter gap here between the original position to the point where the ball started. Okay, so that's why I asked you all to sketch the graph. I hope you all understand this. If you don't understand, don't worry. We still have some more similar practice, okay, later. So coming back to this question, they ask for total distance in the first 2 seconds. So first 2 seconds, where is 2 seconds? 2 seconds is here, right? T equals to 2, because here is 3, so 2 is in front here lah. So do you want to find the distance from here to here? Okay, that's what you want to find. So what you can do is you can find s value when t is equals to 2. So you just substitute negative, okay, I use back the original formula, 6 times 2 minus 2 square plus 7, 12 minus 4 plus 7. So your answer is 15 meter. Okay, so is this the answer? No. Remember I told you all what? Displacement is the shortest distance between the original position all the way to the ball's current position. So in other words, if after 2 seconds the ball is here, right, 15 meters is not this distance. 15 meters is from the original, which is here, all the way to here. This is the distance. This is 15 meter. So if you just want to find here, what do you have to do? You take 15 minus 7. That is the actual distance that the ball has traveled. Clear? Okay, so let me write here. Wait. So distance, total distance is 15 minus 7. So 8 meter. Clear? So question I, this is I, first one is 8 meter. So what about the second one? First 9 meter. So you already know that first 3 meters is here. Then they will travel all the way to here is 7 meters, 7 seconds. So if the ball, you see the graph, if you're looking at 9 seconds, so it should be somewhere here. Let's assume here is 9. So the ball is still continuing to the left. So that means the ball actually exceeds the original position. Let's say here, t equals to 9. So that means you will get your, the displacement here is a negative value, because it's already to the left hand side. So let's do it together. So we first have to find t equals to 3. You want to see how far is the displacement from here to here. Okay, so wait, let's see. So when t is equals to 3, so as, wait, I draw a line here, 6 times 3 minus 3 square plus 7. So you get 18 minus 9 plus 7. Answer is 16. Okay, 16 meter. So 16 meter is from here all the way to here. Okay, so you first of all, you want to find total distance, right? So the total distance is from this position to here and then to here, correct? So on top here you already know is 16 meters. Here you want to find, you take 16 minus 7 to find this one. Okay, after that you need to find the balance 9 seconds to find how many meter is that. Okay, I hope my drawing is understandable. So let us do this together. So now you want to find the second one when t is equal, so this one is t equals to 3. Now you're going to find t equals to 9. Sorry, 7. Oh yeah, sorry, 9. And then here is t equals to 2. Okay, so t equals to 9, you substitute 6 times 9 minus 9 square plus 7. 54 minus 81 plus 7. You should get 45 meter. So 45 meter is, hey, wait a minute, did I get 45 meter? No, you shouldn't get 45, my bad. It should be a negative value. It should be negative 20, sorry. Too fast. My bad. So it's a negative 20. So that means from original here all the way to 9, then 9 second, it has traveled negative 20 meter because it's moving to the left. Okay, so what's the total distance? Total distance should be, so from this position here to here, right? How to find the distance here? You take 16 minus 7. So 16 minus 7. And then from this position you travel all the way back, which is 16 meters again. So plus 16. And then you travel another 20 meters to the left. So you plus 20. Okay, so this one is the 45. Sorry, 45 meter. Okay. So yeah, that's how you, sorry I changed color. So it's 45 meters. Clear? Now question B. Question B is saying find the distance traveled by the particle at the 7th second. So the key thing here is 7th second. 7th means they only want the time between the 6 seconds to the 7 second. They're not asking from 0 all the way to 7. They're just asking from 6 seconds to the 7th second. So 6 seconds is here, right? Let's say t equals 6 is here. So that means 7 seconds the displacement is 0. You already know. So you want to find what is the 6 seconds. Okay, wait. So t is equals to 6. Let's see. So as, sorry, S equals to 6 times 6 minus 6 square plus 7. 36 minus 36 plus 7. So answer is 7 meters. So that means at t equals to 6, the distance traveled is 7 meter. Sorry, so it should be here. 7 meters. So that means this point is t equals to 6. Okay, not just t equals 6. So that means it has traveled total distance 7 meter. Okay, from here, because you know it's 0 ma, correct? So 0, you can just do 0 minus 7, but make sure it's positive value, so it's 7 meter. You still get the same answer. Okay, so that's how you do it. Now I know it can be a bit confusing because a lot of graph and my drawing also is not as good, but no worries, we have more questions after this and I guarantee you'll understand. Okay, so now let's see our next question. A particle moves along a straight line. Its displacement s meter from a fixed point at time is given by, so they give you the function of displacement. Find, question A, instantaneous velocity when t equals to 2. So question A, they asked to find for velocity. So I told you all the relationship, right? SVA. If you want to convert displacement to velocity, you have to differentiate. Okay, and same thing, if you want to find acceleration, you have to differentiate velocity, and if you want to go backward, it's integration. Okay, please take note of that. So now the question asking for velocity and you only have displacement, so you have to differentiate. So v will be equals to ds dt. So differentiation of this. So when you differentiate, you will get 6t square minus 10t plus 4. Okay, so this is your velocity function. So question is asking when t is equals to 2. So you just substitute. When t is equals to 2, your v will be 6 times 2 square minus 10 times 2 plus 4. So your answer is 24 minus 20 plus 4. You get 8 meter per second. Okay, they said meter per second, right? So that is the unit. Now question B. Find the value of t when particle stops instantaneously. So same thing. When the particle stop, you know that velocity is equals to 0. So 6t square minus 10t plus 4 is equals to 0. So you can straight away factorize this. You will get t minus 1, 3t minus 2. Okay, straight away use your calculator. I don't need to waste time already. So just straight away calculate. Then you get t equals to 1 second, and the other one is t equals to positive 2 over 3 seconds. Okay, so that means you have two values. It's either here or this one. Both are positive, right? So it's acceptable lah. At these 2 seconds is where the particle stops. Okay, question C. Find the range. Now when you see range, I told you need inequality. So when there's range, they ask when the particle moves to the right. When it moves to the right, remember, displacement and velocity, there is direction matters, right? If it moves to the right, it's positive. Move to the left is negative. So in this case, they said move to the right. So that means your velocity is positive, right? So it's more than 0. Okay, more than 0. So you will get 6t square minus 10t plus 4 more than 0. So it's actually the same as this. Okay, it's just that this one got inequality. So you should get the same thing equals 0. So I'm going to use the graphical method again. So here is 2 over 3 is smaller, so 2 over 3 is here, 1 is here. Okay, so now the sign is what? More than, correct? It is more than, so it's supposed to be these two area. So that means the answer, right? Your answer should be t, first one is less than 2 over 3. Less than 2 over 3. The second one is t more than 1 second. Now I don't want you all to write like this. Please don't write t less than 2 over 3, because I told you all before, time can never be less than 0. Correct? It can never get negative time. So instead of writing this, you should write t is between 0 to 2 over 3 seconds. Okay, from 0 seconds to 2 over 3 seconds. So these are your answers. Okay, alright, next. A particle moves along a straight line. Its velocity seconds after passing through a fixed point O is given by, so they gave you the velocity here. Find the initial acceleration. So question A, they're asking for initial acceleration. So forget about initial first. We need acceleration. So you have velocity function. How do you find acceleration? You have to differentiate. Okay, so when you differentiate the velocity, you get 8 minus 2t. Okay, so this is your acceleration. Now they said initial acceleration, so that means they are saying that when t is equals to 0, what is your answer for A? So when t equals 0, substitute into your acceleration formula. 8 minus 2 times 0, answer is 8 meter per second square. Okay, so this is your answer. Question B. Find the acceleration when the particle stops instantaneously for the second time. So the first, they said that stop instantaneously. When it stops, what happens? There is no longer any velocity, right? V is equals to 0. So that's what we're going to find first. We're going to use the velocity function to find the time where it stops. Okay, so 8t minus t square equals to 0. So that's the velocity function. Then I'm going to factorize the t, so I get 8 minus t equals to 0. So t is equals to 0 seconds, and also t is equals to 8 seconds. So these are the two timing where the particle stop instantaneously. Okay, but the question is asking for what? The second time. Asking for second time. So this is not the answer then, because this is the first time, right? When t is equals to 0. So you are looking for this when t is equals to 8. So when t is equals to 8, you want to find your acceleration. So you must substitute the t equals to 8 into your acceleration formula. So it's a equals to 8 minus 2t. So t is 8 seconds. So it becomes 8 minus 16, which is negative 8 meter per second square. Okay, so that means at t equals to 8, okay, seconds, the particle is moving at a deceleration. Negative means deceleration. Okay, decelerating at 8 meter per second square. Okay, so question C. Question C, they are asking for find the time when velocity is uniform. So velocity is uniform. In what situation the velocity is uniform? When a is equals to 0. When velocity is uniform, that means velocity is constant. If it's constant, there is no acceleration and there's no deceleration. Correct? So when there's no acceleration, no deceleration, that means a is equals to 0. Okay, if you forgot all this, you can refer to the notes. I already wrote all this in the notes. In what situation v is equals to 0, in what situation a equals to 0, and so on. Okay, so go and refer to the notes. So now in this case, a is equals to 0. They want to find the time. So 8 minus 2t equals to 0. So 2t is equals to 8. T is equals to 8 divided by 2 is 4 seconds. So at 4 seconds, at the 4th second, when t is equals to 4, that is when the velocity is uniform. Alright, so let's see the next question. A particle moves along a straight line and passes through a fixed point with an initial velocity. So you see, initial velocity of, so what does that tell you? You should already know initial velocity means t is equals to 0. So when t is equals to 0, the velocity is 10 meter per second. And then they said the acceleration after passing through through O is given by this function. Okay, so they give you the A function. So question A, they ask for instantaneous velocity when the particle is at 4th second. So first of all, they ask for instantaneous velocity, but you don't have what? You don't have the velocity function. So how do you find? You have to use the acceleration and you have to integrate. Okay, remember SVA. Displacement, when you want to find velocity, you have to differentiate. Velocity, you want to find acceleration, is you differentiate the V. And if you go backward, you have to integrate. Same goes to here, integrate. Okay, please remember this. So in this case, you are looking for velocity, so you have to integrate the acceleration. So when you integrate, so wait, V is equals to integration of 4t minus 8 dt. Okay, so when you integrate, you get 4t square over 2 minus 8t plus c. Don't forget your plus c. Okay, so you simplify this, you should get 2t square minus 8t plus c. Now question is, what is the value of c? So that is why you have this. When t is equals to 0, v is equals to 10. So you're going to substitute. When t equals 0, v equals to 10. So 10 equals to 2 times 0 square minus 8 times 0 plus c. So therefore c is equals to 10. So your velocity function is this 2t square minus 8t plus 10. So this is your velocity function. Okay, A is already given to you. Acceleration function is given to you. So they ask for instantaneous velocity when particle is at the 4th second. So t is equals to 4. So you just substitute into the function. 4 square minus 8 times 4 plus 10. 16 times 2, 32 minus 32 plus 10. So answer is 10 meter per second. Yep, correct. 10 meter per second. So next question. Question B. The minimum velocity. So they ask for minimum velocity. So same thing I already mentioned in the notes. When they ask for maximum or minimum velocity, your acceleration will become 0. Okay, if they ask for max or minimum displacement, your v is equals to 0. When they ask for max or minimum velocity, a is equals to 0. Okay, your acceleration. So in this case, they're asking for minimum velocity. So that means a is equals to 0. So a equals 0, we just have to substitute into the a function. A equals to 4t minus 8. So 0, 4t minus 8. 4t equals to 8. T is equals to 2 seconds. So the minimum velocity happens when t is equals to 2 seconds. So now you have to substitute back into your velocity formula. So v equals to 2 times 2 square minus 8 times 2 plus 10. 8 minus 16 plus 10. So your answer should be, you should get 2 meter per second. Okay, so yeah, this is your answer. Alright, next. A particle moves along a straight line at t seconds after passing a fixed point O. Is acceleration, okay, so they gave you the acceleration function. Particle passes through O with a velocity of 36 meter per second. So what does this mean? they said that when the particle passes through O is what? The original position, right? Right, the original, or you can say the starting point. Starting point. Usually O is, we refer it to the point where it starts, okay? So when it passes through O, the velocity is 36. So what does that mean? It's trying to tell you that when t equals 0, the velocity is, initial velocity is 36 meter per second. Okay, that's what they are trying to tell you. So question A, find the range, say range again, when the velocity is negative. So when velocity is negative, you know v is less than 0, correct? So v is less than 0. Problem is you don't have velocity function, you only have acceleration. So we have to find velocity function. So to find velocity function, we have to integrate the acceleration. So a equals to, you integrate, acceleration is 6t minus 24 dt. So you get 6t square over 2 minus 24t, don't forget to plus c. Okay, so you simplify this, you should get, v equals to 3t square minus 24t plus c. Okay, so how do you find c? That's when you need this. T equals 0, v equals to 36. So 36 is equals to 3 times 0 square minus 24 times 0 plus c. So in other words, c is equals to 36. Okay, so now we can use this, okay, because you already found your velocity function. So your velocity function is 3t square minus 24t plus 36. Okay, this is your velocity function, and it's going to be less than 0 because they said velocity is negative. Okay, when velocity is negative, it means it is towards the left, that means it's towards the left, so it's less than 0. So in this case, you're gonna factorize this. When you factorize, you should get t minus 6, t minus 2 equals to, is less than 0. So from here, you know that t is equals to 6, t is equals to 2, right? So you can use your graphical method. Here is 2, here is 6. So this is less than, correct? Less than is here. So your answer is, the range of t would be 2, is between 2 and 6 seconds. This is your answer. Alright, next question B. Minimum velocity. So minimum velocity is same thing, same as the previous question. Minimum velocity means a is equals to 0. So substitute 6t minus 24 equals to 0. 6t equals to 24, t is equals to 4. Okay, 4 seconds. So when t is equals to 4 seconds, what is your velocity? So substitute back into your velocity function. V equals to 3t square, right? So 4 square minus 24 times 4 plus 36. Okay, you just substitute, you should get 48 minus 96 plus 36. So your final answer is negative 12 meter per second. Okay, so that means it is moving towards the left at a speed of 12 meter per second. Clear? A particle moves along a straight line and passes through a fixed point O with initial velocity. So again, they give you initial velocity of 8. So that means when t equals to 0, v is equals to 8 meter per second. And the acceleration after passing through O is given by, so they give you the function of acceleration. Okay, find the maximum displacement. See, they ask you for displacement, correct? Displacement, and they only gave you what? Acceleration. So from acceleration, how are you going to find displacement? you have to integrate twice, because when you integrate once you get velocity, so when you integrate twice you get your displacement. So let us do that. So first of all, A is 10 minus 6t. So if you want to find V, you have to integrate 10 minus 6t dt. So you get 10t minus 6t square over 2. Okay, so V is equals to 10t minus 3t square. Okay, and then, oh sorry, wait, plus c. See, I also forgot, plus c. So you got a plus c here, correct? So how are you going to find the plus c? That is when you use this. Okay, so when V is equals to 8 and t is equals to 0, you will find that your c value is equals to 8. Okay, I won't write here because it's understood lah. Okay, it's quite straightforward. So you will get your c value is equals to 8. So your velocity function is going to be 10t minus 3t square plus 8. Okay, this is your velocity function. But you cannot stop here because you need to find displacement, right? They ask for displacement instead of velocity. So now you have to find displacement. Displacement equals to, you have to integrate velocity. So you integrate this, you get 10t square over 2 minus 3t cube over 3 plus 8t plus c. So you will get 5, s is equals to 5t square minus t cube plus 8t plus c. So now the question is, how are you going to find c? See, whenever they don't give you this, right, they don't mention it, you can always assume this. Okay, so you can assume that when time is equals to 0, okay, time is equals to 0, your displacement is also equals to 0. That means when time is equals to 0, the particle haven't moved yet. Okay, the object or the particle haven't moved yet. So we can assume that the displacement is equals to 0. Okay, this assumption you can only make when the question didn't mention anything. Okay, if the question mentioned that when t is equals to 0, s is equals to 10, the displacement is 10 meter, then you need to use 10. But in this case, they didn't mention, so we can assume that when t is equals to 0, displacement also is equals to 0. So when t equals 0, s equals 0, you will know that your c will also be equals to 0. Okay, when you substitute, you'll get c also equals to 0. So your function, displacement function would be 5t square minus t cube plus 8t. Okay, so this is your displacement function. Okay, now that you have found the function, now we can solve the question. The question asks for maximum displacement. So I told you all before, when you want to find maximum displacement, your velocity is equals to 0. Okay, velocity equals 0. So use your velocity function, 10t minus 3t square plus 8 equals to 0. So you can factorize this. You factorize, you will get t minus 4 and 3t plus 2. Okay, so that means t is equals to 4 seconds and t is also equals to negative 2 over 3 seconds. So like I said, there is no negative time. There is no negative time. So this one will be rejected. So you're only looking for this. So when t is equals to 4 seconds, that is when you get your maximum displacement. So now you have to take this, substitute back into your displacement function to find the maximum displacement. So when t equals to 4, s is equals to 5 times 4 square minus 4 cube plus 8 times 4. So 16 times 5, okay, this one you get 80 minus 64 plus 32. So your final answer is 48 meter. Alright, question B. Find the distance traveled by particle in the 5th second. So they only want the 5th second. Okay, they are not asking for from 0 to 5. They only want the 5th second. So they want to find between the 4th and the 5th second. Okay, so what's the distance formula? S equals to integrate v dt, right? So v is going to be this function here, right? So you can straight away substitute. You want to draw the graph, so can, but in this case I'm not going to draw. And then you want to know your range. Your range is between 4 seconds to 5 seconds. Okay, so v is your this velocity lah, 10t minus 3t square plus 8 dt. Now please you don't have to integrate again. Why? Because we already integrated to find the displacement formula, right? So when you integrate, you get your displacement function. So you can straight away use this actually. So you can get 5t square minus t cube plus 8t. Now you're going to substitute 5 and 4. Okay, so when you substitute 5, so you get maybe you can straight away count 5 125 125 40 minus you substitute 4, you get 8. 4 is the same as this lah. You substitute 4, so you should get 48. So you will get a negative answer, right? Negative 8. But can you leave it in negative 8? Answer is no, because they ask for distance. There is no such thing as negative distance. So you have to put your modulus in this case. Okay, that means if you sketch the graph will be at the negative side. Okay, so you have to put a modulus to change it to become positive. So your answer would be 8 meter. Clear? So that is your distance. Alright, next. The diagram on the right shows the position and direction of two boys, Far East and Chen Hao, running on a straight path, each passing 2 fixed points. So there's 2 persons here. One is at P, one is at Q. So Far East stops instantaneously at point R. The velocity of Far East after passing through the fixed point P is given, so they gave the function for Far East. And then Chen Hao runs constant velocity of negative 5. So you see it's negative, right? So you know this is Chen Hao. This is Chen Hao because he's moving to the left, right? So this would be Far East. Okay, so Far East, his velocity is 6 plus 4t minus 2t square. And then what's this guy? Chen Hao, his velocity is constant, right? Negative 5. So this guy is v equals to negative 5. Okay, then it is given that the distance PQ, so the total distance here is 50 meters, so it's written there. So question A, calculate the maximum velocity. So question A, maximum velocity is, you want to find velocity, right? So for Far East, by the way, so you can straight away use this. Okay, but maximum velocity means what? A is equals to 0, correct? But you don't have A here, so you must first differentiate this to find A. So when you differentiate V, you will get 4 minus 4t. Okay, so this equals 0, right? 4 minus 4t equals to 0. 4t equals to 4. T is equals to 1 second. Okay, so when the time is 1 second, that is when the velocity is maximum. Far East velocity is maximum. So you want to find maximum velocity, so VF, I write VF as in Far East velocity lah. Okay, so just substitute t is equals to 1, right? So 6 plus 4 times 1 minus 2 times 1 square. So you get 6 plus 4 minus 2. Answer is 8 meter per second. Okay, this is question A. So let's look at the next slide because I don't think we'll have space here. Okay, let's go next slide. Okay, let me just redraw it. Okay, so there's 2 of them. First is Far East. Okay, let me show this guy is running. Oh, not bad, huh? So this is Far East. Okay, he's running to, oops, sorry. So this is 50 meter. This one is P, this is point R, this is point Q. Okay, so this is Chen Hao is here. So this is Chen Hao. So just now we found that the velocity for Far East is what? VF equals to, change color, easier to see. So VF equals to 6 plus 4t minus 2t square, and then for Chen Hao is V equals to -5. Okay, so the question now, question B, they're asking for you to sketch velocity time graph. Okay, so you need the velocity time graph for Far East. So this one, you need this function to sketch your graph. So question B, B1. So first thing, you want to sketch your graph. You know this is the function, right? So you know that it's going to be, it's a quadratic graph first of all, because it's t square, right? So it's a quadratic graph. But is it going to be an N shape or U shape? Because this is a -2 here, so you know it's going to be a N shape graph. Okay, -1. So N shape graph. And the first thing you want to know is the intercept. Okay, you want to find the x-intercept. So when you want to find x-intercept, the y is equals to 0. So in this case, the v is equals 0. So v equals 0, 6 plus 4t minus 2t square equals to 0. So you will find t minus 3, t plus 1. Okay, so the two intercept is, one is at 3, one is at -1, but you don't have to draw -1 because we don't really care about the negative time lah. There's no such thing as -1 second. Okay, so but I'm just showing you guys lah. So it's going to be something like this. Oops. So here is -1, here is 3. Okay, but you don't have to draw here because it's a negative time, so you don't have negative time. So your graph is only something like this. Okay, N-shaped graph, and then here. Oh wait, one more thing. You don't have to draw down. You don't have to draw this part. Why? Because this is Far East velocity, right? When he reached point R, he stops. Correct? That's what the question said. When he reached point R, he stops. So that means when he reached here, he stopped. That's when the velocity is 0, right? At this point, the velocity is 0. So that's when he stopped. So it doesn't continue anymore. He doesn't continue because he stopped. So at this point is what? T is equals to 3. So here t equals to 3. Here is time, here is v. And what is your y-intercept? Y-intercept is 6. Okay. And in the previous question, you also found the maximum displacement. So you can also label the maximum displacement. Okay. So in case you're, okay, wait, what's the maximum displacement? Maximum displacement is 8. Correct? Sorry, maximum velocity, not why I keep saying maximum displacement. Maximum velocity. So maximum velocity is 8. So here is 8. So this is when time t is equals to 1. Just now, the previous question. Okay, t is equals to 1. So in case you all there, time equals to 1, velocity equals to 8. Alright, so you're going to use that to plot the graph. So now you have got this. Question is, they ask, okay, so we already done lah. Basically, we already plot the graph. Okay, next they want you to find the question 2. Find the distance traveled by Far East from point P to point R. So from point P to point R, so you just have to integrate. So displacement equals to integration of v dt. So it's already in the positive, so it's from 0 all the way to 3. Okay, from 0 all the way to 3. And then velocity function is 6 plus 4t minus 2t square dt. So you get 6t plus 4t square over 2 minus 2t cubed over 3. 30. Okay, so you simplify, you will get 6t plus 2t square minus 2 over 3t cubed. Okay, so you can straight away just substitute 3 and 0. I don't have much space here, so I'm just going to straight away write the answer. So you will get 18 minus 0, so your answer is 18 meter. Okay, so the total distance traveled by Far East is 18 meters. So that means from here to here is 18 meter. Okay, from point P to point R, he traveled 18 meter. Now question C. Question C is asking for determine the distance between Far East and Chen Hao when Far East is at point R. So when Far East already reached point R, we need to know where is Chen Hao. Maybe he's here. Let's say he's here lah. Okay, so they want to find the distance between two of them. So that means this distance. Okay, so for me to find that, I need to know how far he has traveled. Correct? But how do we do that? We can use the same time that Far East has spent. So from here we already know that Far East spent 3 seconds, right, to go from point P to point R. Correct? We already found out that he took 3 seconds. That's what we see from the graph. When he reached 3 seconds, he stopped. So that means he reached point R by 3 seconds. So we want to know in 3 seconds how far has Chen Hao ran. Okay, what's his distance? So you have to find question C. You have to find the displacement. So S equals to same thing, integrate v dt, right? So what is the velocity of Chen Hao? Velocity is -5, right? Just now we found out. So velocity is -5 dt, and we are going to go from 0 to 3 seconds. We want to see how far has Chen Hao ran, okay, the distance. So you get -5 t plus c, 30. So same thing. Sorry, there's no plus c, my bad. Plus c is when there is no range given, so it's 30. So you straight away substitute, you will get -15 and then -0, so you get -15 meter. Okay, so that means Chen Hao is running to the left by 15 meters. He already ran 15 meters within 3 seconds. So here is negative, so it's 15 meters here lah. Okay, so if you want to find the distance between both of them, you must take the total length, total distance, which is 50 minus 18 minus 15. That's when you get your answer. So distance between Far East and Chen Hao is, you take 50 minus 18 and minus 15. So your answer would be 17 meter. Okay, this is your answer. So the distance between the two of them is 17 meter. Azim runs along a straight path from a fixed point O. His velocity after passing through O is given by, okay, so they give you the function here, velocity function. M and N are constant. Azim stops to rest after running half of the distance when t equals to 1. Okay, so they gave you a hint here. When t equals to 1, the velocity is, he stops, right? So 0. Okay, with acceleration of 12 km per hour. So they're saying that when t equals to 1, his acceleration is 12.5 km per hour. Okay, so find the value of M and N. So they want you to find the value of what, M and N. So we have to use this based on what they have given us. We have to use this. So the first condition is t equals to 1, v equals 0. So we can straight away substitute into the equation. So v equals to mt square plus nt, right? So v equals 0, t equals to 1. So you get m plus n. Okay, so this is your first equation. Second equation is you have to find acceleration. So from the velocity function, you can find acceleration by differentiating. So a is equals to 2mt plus n. Okay, so that's the acceleration function. So substitute this 12.5 and t equals to 1. So you get 12.5 equals to 2m plus n. So this is a second equation. So you can do simultaneous equation. You can solve using simultaneous. So you can take using elimination lah. So I'm going to take equation 2 minus equation 1. So I'm going to get 12.5 equals to m. Okay, so when m is equal to 12.5, you can find your n value. M, we got m plus n equals 0, right? So n is equals to negative m. So n is equals to negative 12.5 meter. So first question already done. We already found both m and n. Okay. This is not, okay, maybe I shouldn't write. Sorry, that's not m. I thought that's meter, sorry. So this is just negative 12.5. No m there. Negative 12.5. Alright. So question B. Maximum velocity. So again, same thing. Maximum velocity means your acceleration equals to 0. So you already found your acceleration function. So wait, by the way, let us rewrite. So now your velocity function is 12.5 t square plus, negative 12.5 t. And then a is equals to 12.5 times 2 is 25 t plus, minus 12.5. Okay, so this is your v and a function. Okay, just write here so that it's easier for us later. So now a equals 0, right? So 25t minus 12.5 equals 0. So 25t equals to 12.5. T is equals to 12.5 divided by 25 is 1/2 seconds. Okay, so your maximum velocity happened when t is equals to 1/2. So now you can substitute into your velocity function. So v equals to 12.5 times 1/2 square minus 12.5 times 1/2. Okay, so you straight away calculate this, you will get your answer, negative 3.125 kilometer per hour. Remember, because the unit they are using is kilometer per hour. So this is your answer. Alright, question C. Distance traveled by Azim in the second hour. So they only ask for the second hour. So same thing, we want to draw our graph first. So our velocity is this, right? Oops, okay. Okay, so velocity is v equals to 12.5 t square minus 12.5 t. So from here, you know it's a positive quadratic graph. So it's going to be a smiley U shape. Okay, and then the second thing you want to find out is the intercept. What is the x-intercept? So to find x-intercept, v must be equals to 0, correct? So v equals 0. The equation is 12.5 t square minus 12.5 t equals to 0. So factorize 12.5 t. You get t minus 1 equals 0. So t is equals to 1. And also t is equals to 0, yes. So t equals to 1 and 0, 0 and 1. So when you sketch your graph, you should already know the intercept. So let me sketch here. So it's going to be a U shape, right? U shape. Okay. but there's no negative, so it's only here. Okay, so here is 1, here is 0 lah. Here's the origin, 0. Okay, and anything else you need to know? I think we can just use this for now. They said they want to find distance traveled in the second hour. So that means you are going to find here. Let's say here is t equals to 2. Here is the velocity. So you want to find this area. Okay, between 1 and 2. Clear? So you're gonna find that. Wait, I'm gonna space here. Let me see where I can write this. Okay, so I use red pen. So you want to find distance, right? So s equals to integrate 1 to 2, and then your velocity is this one. Okay, so you write 12.5 t square minus 12.5 t. Okay, dt. So integrate this, you will get 12.5 t square as a t cube over 3 minus 12.5 t square over 2. Then substitute 2 and 1. Okay, so your final answer, when you straight away substitute, you will get 25 over 3 plus 25 over 12. So when you add them together, you will get 125 over 12 km. Okay, so this is your answer. So basically we're using the same thing. We're going to integrate the velocity function to find the distance. Clear? So I think that's it. Wait, let me see. Oh yeah, no more question. So that's all actually for this chapter. I hope these questions we have covered more or less give you the understanding of this entire chapter. Of course, just with this is not enough. We have to do more practice. So moving forward, I'll give you guys more videos on all the chapters again, and we see how much we can cover, okay, to give you guys more practice. Alright, so that is all for today. I hope you find this whole entire video useful. Finally, we have completed from chapter 1 form 4 all the way to chapter 8 of form 5. So yeah, I'm so happy with the progress, and I hope you guys find it useful. And if you do like it and you find it useful, don't forget to like and also subscribe, and I hope to see you on my next video. Okay, take care, bye bye.